Imagine, if you will, a reality where you are the president or a reality where dinosaurs never went extinct. Could such realities exist in parallel to our own? This is the captivating question that guides our exploration today as we delve into the concept of the multiverse. The idea of the multiverse, or multiple universes, is a theory that has its roots in the realm of theoretical physics. It's a concept that tickles the imagination and challenges our understanding of reality. It suggests that our universe, the one we inhabit and understand, might just be one of an infinite number of universes, all existing in parallel to each other. This mind-bending idea has been around for decades, but it was only in the mid-20th century that it began to be seriously considered by scientists. The concept emerged as a byproduct of quantum mechanics, a branch of physics that deals with phenomena on a microscopic scale. Quantum mechanics introduced the idea that particles could be in multiple places at the same time, which led some scientists to speculate that perhaps this concept could be applied to entire universes. But the multiverse theory isn't without its critics. Some scientists argue that the idea is untestable and therefore unscientific. After all, if these other universes exist beyond our reach, how can we ever hope to detect them, let alone study them? This debate has split the scientific community, with some embracing the idea of the multiverse, while others remain skeptical. However, it's important to remember that the multiverse is just a theory, and like all theories, it's subject to change as our understanding of the universe evolves. But isn't it fascinating to ponder, to think that right now in a parallel universe you could be the ruler of the world or living among dinosaurs? So is it possible that there are multiple universes out there just beyond our reach? Join us as we continue to explore this intriguing possibility in the next scenes. Now let's dive into a hypothetical story that illustrates the concept of the multiverse. Imagine for a moment two parallel universes. In the first, we find our Earth, the one we are familiar with, the blue marble suspended in space. It's brimming with life, a dazzling array of species, climates, and cultures. The human race in all its diversity has evolved and adapted, creating societies, technologies, and art. This is the universe we know, the one we call home. In stark contrast, envision a second universe, a parallel reality where Earth is drastically different. Here, the planet is twice the size, the air is purple, and the oceans are made of a silvery liquid, unlike anything we've seen. The inhabitants of this Earth are not humans, but a completely different species of intelligent life forms. They communicate not through speech, but through beautiful, harmonious sounds that resemble music to our ears. Their societies are not built on competition, but cooperation. Their technologies are not powered by fossil fuels, but by an abundant clean energy source that leaves no environmental footprint. These two universes, while wildly different, exist simultaneously. They are two distinct realities, yet they are part of the same grand cosmic fabric. How can this be possible? Well, that's where the multiverse theory comes in. According to this theory, our universe is not the only one. Instead, it is merely a single bubble in an infinite cosmic sea filled with countless other bubbles, each one a universe of its own. The laws of physics, the layout of the galaxies, the composition of planets, even the form life takes can differ from one universe to another. This idea allows for the existence of a multiverse where every conceivable variation of reality can occur. Quite a thought-provoking tale, isn't it? But how does this relate to our understanding of the multiverse? The story may sound like pure science fiction, but could there be a scientific basis for the multiverse? Our journey into the realm of the multiverse is guided by some of the most groundbreaking theories in physics, quantum mechanics and string theory. These theories, as abstract and complex as they may be, suggest the tantalizing possibility of existence beyond our known universe. Let's start with quantum mechanics. This branch of physics deals with particles at their most fundamental level. According to its principles, particles exist in multiple states at once, a phenomenon known as superposition. But when observed, they collapse into one state. This leads to the many worlds interpretation, which suggests that for every observed outcome, there's a parallel universe where the particle exists in a different state. Imagine a cosmic game of what if, where every possible outcome is playing out in a separate universe. Next, we have string theory, a theory that has been described as a theory of everything. It proposes that the fundamental particles we observe are not zero-dimensional points, but one-dimensional strings. These strings vibrate at different frequencies, and these vibrations create what we perceive as particles. Now, here's the twist. String theory suggests that our universe might be just one in a vast sea of universes, each wrapped up in higher dimensions that we can't perceive. These theories are undeniably fascinating, but they also present us with tremendous challenges. How do we prove the existence of other universes when we can barely comprehend our own? How do we observe something that exists outside our four-dimensional perception of space and time? These are the conundrums that keep physicists awake at night. So, where does that leave us? Well, as we delve deeper into the quantum world and string theory, we are continually forced to reassess what we consider possible. The multiverse, once the stuff of science fiction, is now a serious topic of scientific debate, pushing the boundaries of our understanding and challenging our perception of reality. Science often straddles the line between fiction and reality. The multiverse theory is no exception. Just for a moment, consider the implications if the multiverse were real. The multiverse theory, if proven true, would fundamentally alter our perception of reality and our place within it. It would mean that our universe, with its billions of galaxies and trillions of stars, is just one of countless others. A drop in the cosmic ocean, so to speak. Let's delve into the philosophical implications of this. If there are infinite universes, then it's plausible to suggest that there's a universe for every possible outcome of every possible event. This concept challenges the very idea of destiny. Is our path predetermined? Or is it one of many routes available in a vast multiverse? Now imagine the practical implications. If there's a universe where you're a famed musician or a world-class athlete, does that diminish your achievements in this universe? Or does it elevate them, knowing that in the grand scheme of things, you've reached your peak potential somewhere out there in the cosmos? Moreover, it brings us face to face with the question of existence and the nature of life itself. If there are infinite versions of us, what makes us unique? Are we just the sum of our decisions, or is there more to our identity than that? The multiverse theory also has profound implications for science. It could redefine our understanding of physics, opening up new fields of study and potentially answering some of the biggest questions we have about the universe. In a multiverse, the laws of physics as we know them may not apply everywhere. This could lead to radical new theories and potentially revolutionary technological advancements. Imagine the possibilities if we could somehow harness the different laws of physics from another universe. Finally, consider the moral implications. If every action and choice has already been played out in countless other universes, what responsibility do we bear for our actions in this one? It's a question that could fundamentally reshape our understanding of ethics and morality. The multiverse theory doesn't just challenge our understanding of the universe, it challenges our understanding of ourselves. So, where does this leave us in our understanding of the multiverse? We've journeyed through the questions, tales, science, and implications of this vast and complex concept. Let's gather our thoughts and take a moment to reflect on what we've learned. We started off with the question of universes. We explored the potential of not just one, but multiple universes coexisting. We pondered on the idea that our universe might just be a small part of a grand cosmic ensemble. And the thought itself is awe-inspiring. Next, we dived into the tale of two universes. Here we encountered the concept of parallel universes, where an alternate version of you might be living a different life. It's a fascinating hypothetical story, but one that is supported by some scientific theories. Then we delved into the science of the multiverse, quantum mechanics, string theory, and inflationary cosmology. These theories offer us a glimpse into the possibility of a multiverse. They suggest that our universe could be one among an infinite number of universes, each with its own laws of physics. We also discussed the implications of a multiverse. If a multiverse exists, it would redefine our understanding of reality. It could answer some of the biggest questions in physics and cosmology, but it also presents challenges in terms of empirical verification and philosophical interpretation. And now, here we are, wrapping up our exploration of the multiverse. It's been a mind-boggling journey, hasn't it? But remember, this is just the tip of the iceberg. The concept of the multiverse is still a topic of ongoing research and debate in the scientific community. So keep your curiosity alive, continue to question, explore, and marvel at the mysteries of the cosmos. And remember, science isn't just about finding answers, it's about asking better questions. Whether or not the multiverse is real, one thing is certain. The universe we know is far more complex and fascinating than we could ever imagine.